Yes. Oh no, Tabitha, she had to walk home from prom. How awful. Not fun. Well, here are, I should say, well, it'll copy the recording, or the links that are on the screen there. So we're going to start talking about special right triangles, and this works very similarly to trig, where at first you're going to go through this and you're going to be like, what are you talking about, Mrs. Williams? This is craziness. But if you keep practicing, you'll get it. Okay, so it's just, again, this whole unit is kind of one of those things where at first you're like, what? And then after you practice enough, you get it. So here are special right triangles. The reason, yeah, see, so you've practiced enough, Tabitha. You like it now. And if you practice enough, I think most students actually end up really liking trig once they get it. But I know until you don't get it, then it's not so fun, right? Yes, exactly. Exactly. It has been. Once you get going, like at first, do you guys agree when we first did that, you were like, what are we doing? For the first few problems, right? And now that you've gone through a few, you're like, oh, well, it's not quite so bad. See? Yeah. I know what I'm talking about, right? Every once in a while. All right. So special right triangles. Now, trig will also work on these, okay? So that is a possibility. The reason that we go over this a different way is just that they occur. I mean, one reason is that they occur a lot in you know, real life applications, especially like construction and things like that. And so sometimes this, if you know these ratios, it's just a little faster than sitting down and doing sine, cosine, and tangent. Okay, so the reason they're called special is because of the angles. So the first one, if you look at the, now one thing you want to note, both of these triangles are right triangles. So that's one thing you want to note. And the first triangle, the other two angles besides the 90-degree angle, the two angles are 45 and 45. Okay. So another special thing, this first one's special not only because of the angles, but it's also special because it's an isosceles triangle. Remember, that was if you have two angles that are the same or two sides that are the same. In this case, we know the angles are the same, so that means the sides across from those angles are the same. And so that's just one thing to pay attention to. So you'll see that both of these are labeled A for that reason, because it's an isosceles triangle, okay? And then the hypotenuse is labeled square root 2 times A. Okay, so that's what that means. So we'll do some problems here in a minute, but you'll start to get the hang of it. How it works is that if you know what this side length is, so for example, let's say it's 5, then this one you know already has to be 5. And then to find this one, you just take that 5 and multiply by the square root of 2. Okay, so if you know this side length, you go boom, boom, you're done. Okay, so if you know those ratios, then it's fairly quick. And then over here, same idea is going to apply. I used S instead of A, but it's the same idea. If you know these sides, now I gave it to you. Okay, so one thing you want to know is that kind of think of it as the ratio. Okay, so you want to know, you want to be able to label the triangle correctly. That's really the key thing here. So with a 45, 45, 90, you want to know that the two sides across from the 45-degree angles are in a 1-to-1 ratio, okay, or A to A, and then the hypotenuse is square root of 2. Okay, this one we call a 30, 60, 90, and again it's because of the angles inside of the triangle. It's only going to work if the angles are 30, 60, and 90 degrees, okay? And the ratio of the sides is 1 square root 3, 2, okay? And I changed my triangle from last year's PowerPoint, and I'm kind of regretting that. Now, let me change it back. I know, see? I told you, Tristan. Right now you're going to be like, what are you talking about, Mrs. Williams? So let me change this. I'm going to just use A. Okay. Because I like it like this better. I think this is easier to understand. They were doing, what they had wasn't incorrect, but I think I would rather have you guys just remember these ratios. So the side across from a 30-degree angle is a 1A, or just A, but that's where this 1 here is coming from, is the number in front, the coefficient in front of the A. Okay, the one across from a 60-degree angle, you're going to label with a square root of 3A, and then the one across from the right angle is going to be 2A. Now, oh, I didn't see what you wrote, Keely. Yeah, exactly. So yeah, you guys are done. You have to take through geometry, but practical math is a great next course if that makes sense for you guys. Yeah, it is very practical. I'm teaching it this year, Tristan, and it is like the name. Now, I kind of don't like it in one sense because really all this stuff is practical as well. You guys just don't see it as easily. With practical math, you'll see, oh yeah, this is very practical, and you'll be able to see the practicality of it. I know that's what's hard with this. You don't quite see that sometimes. So here's the key, okay? So just like with trig, that was confusing at first, and the key was to know the ratio, like Tabitha said. Okay, the key for these is to know, or to know SOHCAHTOA was for trig. The key here is to know this ratio. Okay, 1 square root of 2 for the 45, 45, 90. 1 square root of 3, 2 for the 30, 60, 90. Okay. Now down here, I'll give you a hint. Because students will remember the numbers, but then they won't remember where they go. So remember how we talked about if you have the smallest angle is always across from the smallest side, okay? And the largest side is always across from the largest angle. So that will help you remember, okay, the 30 is the smallest angle, so the 1 goes across from that angle. 90 is the largest angle, so the 2 goes across from that angle. And then process of elimination, square root of 3 has to go across from the 60. Also because if you take the square root of 3 and convert it to a decimal on your calculator, you'll see that that's 1.7. So you can see that that's going to be in between the 1 and the 2. That's the middle side. Okay? Now I know this is still as clear as mud at this point, okay? This is just background information. So let's practice some, and I think this will make it a little bit easier. So let's start out really easy, okay? All right. So let's say that let's say I tell you that this side is 3. Okay? Let me give you whiteboard privilege and see if you guys can maybe fill in the other sides. What do you think the other sides would be? See, I told you guys you'd get the hang of it. This looks great. Perfect. Absolutely right. Okay. Now, one thing, if you leave it, so sometimes, okay, this is kind of one of those things like when we were talking about pi, when we were doing Unit 4 with circles. Sometimes we'd leave it as pi and sometimes we'd change it to a decimal, right? Well, it's kind of the same thing will work over here on this side where, yeah, exactly. If you need to change it to a decimal, you can do that. You can take the square root of 2, put that in your calculator, and multiply it by this 3. Excellent, 4.24, okay? If you don't change it to a decimal, we actually should put the 3 first, and then the square root of 2 would go next to it. Okay? So that's just kind of how we write square roots, just because we don't want to, or this would be fine too. I like how you put the parentheses there. That's good. That way we don't accidentally think that the 3 is underneath the square root. It's just the 2 that's under the square root. Okay? So this is the more traditional way to write it there. Beautiful, okay? So you guys can see if you know that this is A, then this is also A, so it also has to be 3, and then, oh, well, A is 3, so I can put 3 there. Beautiful, okay? All right, I'm going to clear the page, and I'm going to give you something different. Let's say this time you knew that the hypotenuse, let me use color here. Let's say you knew this side over here in pink, that side was 5. How do you think you'd find the other two sides? Any ideas? It's a little harder that way, right? Because you don't know what A is. Good. Excellent idea, Yusuf. Yes, you want to use algebra. Good. Yes, well, that's right. Good, Ben. All great answers. Exactly. So I'm going to set this up using algebra. So Yusuf's perfectly right. So the 5 and the square root of 2a are both along that hypotenuse. So they have to be equal to each other, right? So I can use algebra to set them equal to each other. And I'm going to write it as a square root of 2 instead of square root of 2 times a. Actually, I'm going to go back a page. I'm gonna just write it that way. Actually, would be the better way to write it. Let's write a square root of 2. Okay? I like that better. Same thing over here. Let's do that. Let's do a times the square root of 3. Okay? All right, Brian. 3.2 he's guessing for a here. All right. But yeah, Ben and Will are right. If you set it up as an algebra problem and you're solving for a, what you end up doing is dividing by the square root of 2. Because the square root of 2's cancel out if you do that, and you get a equals, and then, okay, so yeah, depending, I guess, where you round it to, you would take 5 and divide it by the square root of 2 on your calculator. And yes, 3.54. So we could, you know, depending on where they rounded it, 3.5, 3.54. Excellent. Excellent, excellent. And then that would mean this side is 3.5 and this side is also 3.5, right? So once you get A, the other two sides are easy because they just have an A on there, no other number. So you're done, okay? So the key is really what Yusuf said. You got to set it up as use algebra, okay? If you know, and that's really what we did on that first one when I told you, okay, well, say this is 3. You guys didn't probably do it formally, but that's what you did in your head. You said, oh, okay, I'm going to make a little algebra equation. A equals 3, and then I'm going to go from there, okay? So same idea. Whatever two things you have on that side, they have to be equal to each other. If they're equal to the same side, they have to be equal to each other. And so show that algebraically, show what that means, and that'll allow you to solve for A. Okay? Does that make sense? Okay, well, we'll keep practicing. Like I said, it'll start to become clear the more we practice. But let's move on to, oh, I had an extra one in there. Let's move on to this one. And the first thing I'm going to do, hold on, let me fix these ratios. I should have just left what I had in there last year. Let me fix this because I don't like how this is written. 1 second. Oh, you're okay, Delia. The rest of it's recorded, so you can go back and catch the beginning. I think this will catch you up pretty quickly. Actually, I'm glad I erased that. Okay, so let's practice, okay? Remember how I said the hardest part of this is probably going to be remembering the ratio and how to know which ratio goes on which side, okay? So on the 30, 60, 90, my suggestion is start with the 30, but it's up to you. Once you start practicing enough and you get the hang of it, you can start with whatever side you want. But for now, let's start with the 30, just so we're all in the same place. What ratio goes across from the 30? Anybody remember? Let me maybe come back up here. Let's write, the reason this is called special is because of the angles inside of it. It has a 30, a 60, and 90 degree angle. Yes, and it's A. So let's recall what the ratios are. So it's 1 blank blank. Which one goes across from, do you guys remember the ratios? What are the other two numbers there that we need? What one goes across from the 90? What's the largest number in that ratio, if you remember? Yep, square root of something, Tristan, not across from the 90. Square root of 3, which one, where does square root of 3 go? Yep, Brian has the 90. The 2 goes across from the 90. Yep, and the square root of 3 goes across from the 60. Beautiful. Okay, so across from the 30 degree angle. And again, yeah, here you can add the A's if that helps. Okay, so 1A or just A goes across from the 30. Across from the 60, because it's the second biggest angle, we want to put the second biggest side. And then across from the right angle, which would be the largest angle in there, we want the largest side. Okay? So again, the reasoning there is this is the smallest angle, 1 is the smallest number, 90 is the largest angle, 2 is the largest number, because if you take square root of 3 on your calculator, that's about 1.7, which is in between 1 and 2. And 60 is in between 30 and 90. Okay, so that's how you remember what goes where. All right, so now let's say I gave you a number. Let's say I told you that this side was 5. What would you do with the 1a and the 5? What do you know about the 1a and the 5? And I know this one's the easier way to go, but I'm just trying to get you to make sense of it with the easy way. Okay, good. Good to filling it in. Awesome. Exactly, Tristan. So 1a, or just a, has to be equal to 5 because they're both on that side. 1a and 5 are equal. Now that you know a, exactly, I love, I don't know who filled in the 10, but that's right. Okay. Oh, Brian did. Awesome. Thank you, Brian. That is correct because we would simply take 2 times 5. And we'd get to 10 right here. Okay? Good. And now we know that a is 5, so we can put 5 right there. Yep, and use your calculator if you need to. Depending, again, it might depend on, if you're on a quiz, you have multiple choice answers, you'll want to take a look at those and see, occasionally it might leave it in square root form. So 5 times the square root of 3 is an acceptable answer. Or, okay, let me double check this. Let's see if there's some discrepancy, looks like. I got, yeah, 8.66. So this looks good. Yep. Okay, so either one of those, it depends on whether they round it and put in the decimal answer for the square root of 3 or leave it as the square root of 3. Okay? All right, let me give you another one. I like that, Ben. According to your awesome calculator, yes. We love our calculators, right? Oh, and then I deleted my little, covering up that S. Okay. See if I can do this without erasing all my stuff here. Sorry, I'm erasing your work, but we're going to do a different problem now. Okay. All right, so now let's say that I told you, and if you haven't already guessed, the 30, 60, 90 triangle is the harder one of the two. Let's say I told you this side, the hypotenuse, let's put it in, I'll put it in green. Let's say I told you that this hypotenuse over here is equal to, oh, let's do 14. Okay, so let's say I told you this side over here is 14. And I said, okay, find the other two sides. Good, right away, 7. How did you get that? So what are you doing with the 2a and the 14? How did you know that a was 7? If you guys want to use your mic, feel free. Good. I like that explanation, Ben. So again, you want to realize that both of these, the 2a and the 14, are both different ways of labeling the hypotenuse. And so they have to be equal to each other. So you want to say, okay, well, I have two things over there that are equal, so I'm going to make a little algebra equation out of those. I'm going to put an equal sign between them because they have to be equal. And then I'm going to divide by 2 to get a. Because if I have a, then you can just simply plug a into the other ratios. Okay, so if you do that here, we got 1 times 7, which is 7. Okay, so what we're doing is we're just taking that 7 and plugging it in. And then the same thing over here, we're going to take the 7 and plug it in over here. 7 times the square root of 3. So you can either, again, leave it as 7 square root of 3 or plug it in your calculator. I'm assuming that is correct. Yep, 12.124. Yes. Okay. All right. So then we would know that this side of the triangle is 7. This side of the triangle is 12.12, and this side is 14. Okay? How are you guys feeling about those two? The two examples we did here for the 30, 60, 90. Okay, good. I think it's a little easier than trig once you get the hang of it, right? And see how it goes pretty quickly. It's faster than trig once you get the hang of it. And like I said, you know, you can use trig here. It's just a shortcut to make it a little faster. Yes, exactly, Tristan, exactly. Let's see, I was going to do something. What was it? Oh, that's what it was. Okay, so let me do one more. I'm going to give you one more example. We'll do this. Let me just erase all that and put my little white boxes back over here. I think that'll be faster. Okay. So I'm going to just leave it blank like that. And I'm going to tell you, I'm going to make it a little harder for you. I'm not going to fill everything in. I want you guys to practice filling in the ratios. I'm going to tell you that this side over here in blue is 10. Okay? So I want you guys to work this out just for a minute or two on your own. So don't type anything in the chat or write anything on the whiteboard just yet. I want you guys to, everybody to try this. See if you can, first of all, label the sides correctly. And then from the 10, figure out what this side would be and what this side would be. And then I will take a volunteer in a minute to finish it up on the board for us, okay? Yep, that's right, Tristan. So 10, there's going to be a square root of 3 involved there. So if you want to send your response to me, I'll let you know if you're on the right track or not. Okay, good. So it looks like some of you are getting the hang of it. Awesome. Yes, very good. Anybody want to get us started on the whiteboard? All right, Brian. Brian was first. You guys are all quick on the draw, though. Awesome. Thank you guys, Brian, Ben, and Tristan, for volunteering. Okay, there you go, Brian. You can get us started there. Okay, beautiful. So Brian is showing us that the correct label across from the 60-degree angle would be the square root of 3. Okay, so he said, okay, well this side over here is a square root of 3. That's the ratio that goes over there. And so a square root of 3 and 10 have to be equal to each other. Oops. So Brian divided by the square root of 3 there. Good, good. And then, oh, let's see. I'll just double check that decimal just to make sure. Oh, yeah. I see. Well, okay. So, yeah. Brian, you divided by 1.7, I think. And, yeah. Or, let's see. 10 divided by 1.7. Yeah, you'd get 5.9. Yeah, so that, I guess, might be one thing you would want to do. It is approximately 1.7. So depending, I guess, on, you do get a little bit of rounding error if you just use 1.7. If you have a calculator, probably the best way to put it in, just so you don't get too much rounding error, would be to go ahead and put the square root of 3 in. You are right, and like I keep telling you guys, square root of 3 is approximately 1.7. But if you round it at this point, then that will continue throughout the problem. And I don't think you'll probably run into trouble, but you might be a little bit off, like if you had a multiple choice answer. So, you know, that's just a caution there. If you actually, I mean, you're going to probably use your calculator for all this anyway. You might as well go ahead and throw in the square root of 3 in your calculator. Yeah, or use like 1.73 instead of just 1.7. Yeah, just so you don't get too much rounding error there. But exactly, that's perfect. Other than that, which I don't blame you for doing that because I told you it was 1.7. So I know why you did that. But that's beautiful. Thank you, Brian. Give Brian a round of applause. Excellent, excellent job. So here he found A, and the side across from 30 is equal to A. And so he said, okay, well, there's no work to do there. I just throw the 5.88 there, or the 5.77, depending on how you put it in your calculator. And then over here, he doubled it because the ratio across from the 90-degree angle says take 2 times whatever your A value is. Okay? Yeah, so that's pretty close, Brian. I think definitely 1.7323 would work. Probably even just 1.73 would get you close enough. So if you don't like using that square root button in your calculator, that would work. If you end up where your answer isn't close enough to one of the multiple choice answers to match it up, you could throw in the 1.7323 and see if that gets you to the answer that is in your choices. Okay? Now, one thing before we move on, I want to talk about here. Occasionally, you will, on this side, they will leave the answer in square root form, and they won't convert it to the decimal of 5.88 or 5.77. So there are a couple things you could do there. One would be if you see the square root, like if you converted your answer to decimal form, you could take the multiple choice answers, convert those to decimal, and see what matches. Okay. The other thing that I want you guys to remember, and this is back from Algebra 2. Yes, I see where you're going there, Brian. That is totally fine. I understand that. So I think you'll get by with being lazy if you do 1.73. You'll be good. What you want to remember from Algebra 1 is that if you have a radical sign in the denominator, that's actually a no-no. You're not supposed to do that. And what you want to do is get that out of there. How you do that is you just multiply by whatever the square root is in the numerator and the denominator. Okay? What you end up with would be 10 times the square root of 3 over 3. Because whenever you have 2 square roots that are exactly the same, the number down there under the square root, it just pops out of the square root. Okay, so this is actually the correct way to write it, and this would be considered incorrect. So you never want to leave a radical sign in the denominator. That is not polite math etiquette. Okay? So just an FYI there. Like I said, if this were one of your multiple choice answers, and you're like, what? I do not have that here or here. What in the world is going on? You can, if you have multiple choice, use your calculator to your advantage. Take 10 times the square root of 3 and divide that answer by the 3, and it should match up with your decimal. Okay? You mean this one here, Delia, or the decimal? Yes, you can. What I was going for here, Delia, is that you might see something like this in your multiple choice answers, like on your quiz or your test. And if you need to match this with your decimal answer, you could go ahead and put this all in your calculator and see if the decimal here matches with this decimal. I would be careful. This would be one case where I'd probably go ahead and use the 4 decimal places so you don't get too much rounding error so that it actually does match with your answer. So yeah, does that answer your question, Delia? Okay, perfect. Yeah, well, it's just a lot of, like the 45, 45, 90s, those will occur a lot, like, construction applications because you have square corners, and then like other boards, a lot of times, like if you're, I don't know how many of you are familiar with woodworking, I'm not real familiar with it, but my father-in-law does a little bit, and so you have machines that will cut 45-degree angles, so that type of thing will happen in construction. The 3069 is probably not quite as common, but in surveying, sometimes these triangles and trig too will come up quite a bit. So, okay, perfect, Delia. All right, let's see what else I have.